Here, I think looks like might have to enable screen sharing.
Oh, yeah, no worries. Here, let me just. There we go. Does that give you screen sharing capabilities?
Yeah, looks like I have it now. Let's
Perfect.
go.
Okay, amazing.
Can you see that okay?
Yep, looks good on my end.
Okay, welcome everyone. As Kara mentioned, I am a professor in the newly minted Department of Earth, Energy and Environment, formerly called Department of Geoscience. I'm very excited to talk to you today about my field and the programs that we have in our department, which might be of interest to many of you. So as I was asked to do this sample lecture, I thought about a couple of decades ago when I was going to university, and my mind was actually really cluttered at that time in the sense that I didn't really quite know what I wanted to take at the university. So if any of you feel like that, and that's perfectly okay, because part of the excitement about university is actually finding something that you're passionate about, right? And if you don't have that idea of what you're passionate about right now, and that's perfectly okay. You're going to find something that you're passionate about, and that's what university is about. And University of Calgary offers a number of programs that are exciting, okay? But I want to talk about my field, which I think is the most exciting of all of those, right? So when I went to university a long time ago, I did not have an idea of what geology was, and I only learned it in the program what you can do as a geoscientist. So when I was asked to make this sample lecture, I thought it would be best to talk about what is geoscience and give you an idea about what do geologists or geoscientists, as we call them, do. And that will probably give you an idea of what are some of the skills that you need to learn, and which is what our program focuses on, right? Basically teaching you that skill so you can go out and be a geologist or a geoscientist in a variety of different fields. So if you don't know already, geology is a science, right? And the word geology is derived from the Greek word geo, meaning earth, and logos, meaning the study of. So it's essentially the study of the earth, but it is a science, right? So it's the science of the earth. And what we study is, in a nutshell, but not limited to, it's a study of the processes, the products, and also the history of the earth, which has very interesting applications in society, which we will have a chance to talk a little bit about today. Okay, so obviously I use the term geoscientist and geoscience. So basically that means geology is a science, right? So when I went into geology, I did not know, okay, what kind of science is geology? I have heard about physics or chemistry and biology, math, and now even computing science, but what is geoscience? But geoscience is essentially a hybrid of all of these, right? So there is no such thing as a separate science of geoscience. What we do in geology is basically apply the different fields of science like physics, chemistry, and biology to actually study the earth, right? So in other words, it's an applied science. And that's what actually makes geoscience very appealing for me, because we're not just actually learning some science for the sake of learning science. We're actually applying that science to actually study something about the earth processes. So being a science, and as you probably know from your little introduction that you had in your high school, that science is about understanding nature, right? And it's about observing nature and making some meaning out of it, right? So the first step in doing geoscience then is actually to collect some scientific data, in this case, geologic data. And one of the fundamental ways in which geologists collect data is actually by doing field work. So I have a series of images from the fieldwork field schools that I have led students to. So the leftmost one here is, I don't know if you can see, there are some students right up here who are just doing fieldwork in Montana. The middle one is a volcanology field course that I teach in Hawaii, where students are actually looking at this rock, which is a product of some explosive volcanic eruptions. Okay, and then the image on the right-hand side is also a student taking some measurements of rock layers. And so one of the things that we do in our program is basically train the students in a variety of field work, not just in rocks. We also look at water, chemistry, snow surveys, and things like that. Basically, how to collect data in the field, right? Which goes as a fundamental data that we use to study the Earth. Okay, there we go. So field work actually takes time, right? Because you can only work in a limited area at a time. And so sometimes we also get field observations using satellites, right? Satellite-based instruments, like, for example, on the left-hand side, it's a radar image. It's a composite image. So this is an area, an active volcanic area in Hawaii, right? Where you're actually taking images of the land surface at different times, and then comparing the small changes in elevation that occurs as a result of magma intruding into the volcano. So these colored fringes that you're kind of seeing is actually showing ground deformation at a very, very small level. And that can actually help us understand how the volcano is behaving, is the magma basically being supplied to the volcano, or is it being drained away to some other locations? So that's kind of useful in kind of predicting the behavior of a volcano during different times. And then on the right-hand side, this is a simple GPS-based measurements of how the ground is actually moving, in this case, focusing on the western part of the United States. So as you know, in California, right, there is a high hazard for earthquakes, which is primarily because of large-scale movement of the tectonic plates of the Earth. So this is kind of showing those movement. And again, you can see that you have large relative movements, which is indicated by the length of these arrows. It's showing that there is large-scale movements near the coastal areas in California. But as you go into the interior part of the United States, you don't see that type of movement, right? So again, it's kind of showing where the ground is actually moving, and also kind of telling us where potentially some earthquakes could occur. So that's using some field-based observations. And so one of the goals of collecting the field data is just to produce field maps. So this is a geological map of Alberta. So you probably have seen maps before, but this is actually showing the distribution of geological formation. So this is one of the products that you produce by doing field work. And even though it looks very simple, it's a very useful tool for people who are planning the utilization of resources. Without going into much details here, it also kind of shows the different ages of the formation. So for example, the formation or the rock that's kind of written here as Milk River is actually the oldest in this region. So as you can see, that occurs at the surface in this area. And then we have other rock units of different ages, right? And that can help understand where some of these resources might be in some of these formations, but also from a groundwater point of view, right? So these different formations have different properties in terms of their ability to hold water. And so if we have to use groundwater for various purposes, we know fully well where we need to dig the well into. Okay, so that's one of the ways in which you can use these products of field work, basically the geologic map. Other type of field data. So this is basically, now we're looking at this seems to advance faster or with a delay. So this is actually looking at a cutoff view of the Earth. So this is actually showing using earthquake waves to map rocks that are beneath the surface, right? So as geologists, we're not only just interested in what occurs at the surface, but also what occurs underneath. And so geophysics, basically applying the physical properties of rocks, which is manifested in how earthquake waves travel through the rocks, which can then help us make up these underground maps or subsurface maps, which help delineate various features, including these lines here are actually what we call faults or fractures, which could be areas where slippage could occur. And so that's again used in making hazard maps like this. So this is an earthquake hazard map of United States, but there are maps available for Canada as well. And so in this map, basically the highest hazards are shown as these really bright colors. And then these lighter colors are basically areas where seismic hazard is low. So, and these kind of hazard maps are prepared by looking at various information, both at the surface and also at the subsurface. And then we also have lab-based observations. So for example, the image here is that of a volcanic rock called basalt, which you might be familiar with. This is the stuff that erupts in Hawaii, for example. But when you look at it at this scale, it doesn't really show anything. But what we do is basically create a thin slice of the rock, which we glue it onto a glass slide, and then we can observe them through the microscope, which kind of shows these different minerals in the rock, right? And the minerals can actually tell us a lot about the conditions of formations of the rock and what kind of environments in which they form and so on. Okay, and again, more lab-based observations. These slides seems to be advancing slightly faster. Yeah, okay. In addition to looking through the microscopes, we can also look at the chemistry of the rock, right? So the same basaltic rock, right? We can use sophisticated instruments to look at what kind of chemical elements are in there, which can also be used for a lot of purposes, including understanding the formation of the rock and also look at what sort of resources might that rock contain, right? And that basically involves kind of powdering the rock and then using some high-tech instruments. And there are quite a variety of instruments that we use. And as a student, you get trained on looking at these data and how to make sense of it, right? Or you might be interested in looking at the water samples, right? What is the quality of water, right? And so you can compare that to the standards that are out there. And there are people who even go into look at the isotopes of elements to, as shown in this image here, just to think about where the different products of geological processes actually come from. And one of the other things that the geologists do is basically figure out the history of the Earth, right? The Earth is 4.5 billion years old, and there is a number of big changes that the Earth has undergone during that 4.6 billion years, right? So one of the goals of the geologists is to actually figure these out. And of course, the geologists kind of help track environmental changes. So one of the defining challenges of modern day is climate change. And as you know, we make continuous measurements of carbon dioxide. So this is done in a mountain in Hawaii, and this is kind of showing the change in CO2 in the atmosphere, right? Even though carbon dioxide only forms a tiny fraction of the atmospheric gases, currently at around 427 parts per million. So that's a tiny fraction, but it is one of the big greenhouse gases, which is actually producing the global warming that we're experiencing today. So we look at modern environmental changes, right? But we also look at past changes, because for us to understand what's happening today, we also need to understand what has happened in the past and the rates at which that happened. And this is kind of shown here. This is showing the temperatures relative to the surface temperatures between 1961 and 1990. So as we know, now we have this global warming, which has basically increased the temperature by nearly 1 degree Celsius prior to the Industrial Revolution. But as a geologist, we might actually be interested in figuring out what was the temperature at the Earth's surface before that time as well, right? And we did not have thermometers as you go back in time. And so we will use different proxies for measuring temperatures, like looking at isotopic composition of ice cores and corals and so on, which can tell us something about the temperature. And so those are some of the things that you will learn as part of being in the geology program. Okay, and then one of the biggest role that geoscientists play in society is basically finding resources that are important to society, right? So we use a lot of resources that comes from the Earth. In fact, anything that we don't grow, it basically comes from the plant, comes from the Earth. And you can show this. This includes energy sources, which is kind of outlined in green. There's also all kinds of metals that are important in the various industries that enable us to sustain the high quality of life that we enjoy today. And then there is also a lot of other materials, like building materials, which also comes from the Earth, right? So one of the goals of the geoscientists is basically to help find these resources. To kind of address the relevance of that today, if you think about the technological innovations that has happened, and many technological innovations actually require more metals to make that happen. So as an example here, this is kind of showing the evolution of the computer chip technology through time. So in the 1980s, there were only 12 elements in the computer board that we use, but by 1990s, we added 4 more elements. So basically about 16 elements were in the computer. But now if you look at the computers, they nearly contain about 60 odd elements in the periodic table. And if you remember the periodic table, there is 94 naturally occurring minerals. So more than 3/4 of the elements are actually used in just the computer chipboard, right? So that kind of highlights the fact that technological innovations actually require finding more metallic resources in future. And the other thing that we know that's driving a major change today is basically the move from conventional cars to electric cars as a measure to combat climate change. And that again will add more demand for metals. And this is kind of shown here. So the conventional cars primarily uses copper and some manganese as the two primary metals. Whereas if you look at the electric cars, in addition to copper and manganese, we need metals like lithium and cobalt and graphite, which are primarily used in the batteries of electric cars. So to make these transition to electric cars, we actually need to find more of these resources. And then if you have been paying attention to the news lately, all right, we are going through an extreme drought in Alberta, and that's not just a year in making. It has been occurring for nearly 2 decades. But this year it's exacerbated by the El Nino, which is a ocean upwelling phenomenon that occurs in the Pacific, which is adding to the drought conditions. So the image here is from the St. Mary's Reservoir boat launch, and you can see how far away the current water level is actually from where the boat launch used to be. Okay, so again, to manage water resources in Alberta and elsewhere, we need to know how the precipitation and also the groundwater changes through time. And so that is one of the roles that geologists play. Okay, so in short, it would not be a stretch to say that some of the grand challenges of the world today requires a very interdisciplinary approach, right? It cannot be solved by any one particular field. And geoscience, as I mentioned, is inherently an interdisciplinary field where you actually learn to apply principles of chemistry, physics, biology, math, and computing science to solve geological problems. So it, in a sense, actually makes you a very broad scientist who can work in a number of different career fields. And I think my next slide is an image from the Geological Society, which is a British Geological Society. And they kind of made this infographic kind of showing how geoscience play a role in many of the sustainable development goals that has been outlined by United Nations. And they have identified 17 sustainable development goals in future. And what this infographic kind of shows is that the geology plays a major role in achieving many of these sustainable development goals. And essentially what that means is a lot of different careers in different fields. And then I think my next slide is probably the final one. So the geology actually has a number of different specialized fields. I wouldn't go through the names of these, but basically our program will basically give you a broad introduction to all of these fields so that you have multiple career paths once you come out of the program. And I think by going through the program, you will find your passion in one of these fields, and perhaps that's where you will take yourself to. But it is important to know that geology doesn't force you to work in any one particular career, right? It's actually a very broad field with wide applications in society. So I hope you will have a chance to look at the programs, the geoscience programs in the Earth, Energy, and Environment. In particular, we have a program in geoscience, we have an environmental science program, and there will be an energy science program coming very soon. I kind of mentioned that because it's not a program that we run currently, but it is going to be implemented pretty soon. And at University of Calgary, we have flexible system where you can move through the program should you find something more interesting. So that could potentially be something that you're interested in. So I'll stop there for now, and I'll be happy to answer any questions after Kara's presentation.
Thank you so much. That was so insightful. I know I have a couple people in my life who have a geoscience degree, and they kind of, it was really cool when you showed that map, kind of seeing what they do on there, but then all the other things that you can do. That was really, really, really cool. Thank you so much. I'm just going to share my screen now. There we go. So if you haven't come to any of our sample lectures before, this is just my admissions presentation for the geology program in particular. So this is just about the University of Calgary and then some specific things about the university in general. So you can see here, this is just our school at a glance. So some of the kind of quick statistics are we were founded in 1966. We have about 28,000 undergraduate students, 5 campuses, and 14 faculties. And those ones are all our undergraduate faculties, or we have 10 undergraduate faculties, and then 4 of those kind of like postgraduate faculties. So that's law and medicine and all that kind of stuff. But that's quite a bit to do in the less than 100 years that we've been, open. We are Canada's entrepreneurial university as well. We have about $504 million in sponsored research funding. And then these ones are my last 2 favorite statistics. We've got a 94% after graduation employment rate and a 95% undergraduate retention rate. And that undergraduate retention rate speaks to student life satisfaction on campus. So satisfaction with professors and classes and what you're learning and the different student supports that you can get on campus. And speaking as a student myself, it is something that, I'm very passionate about kind of sharing with future students and future dinos at UCalgary. So our admissions is going to be based on 5 faculty specific grades from 5 specific classes. So it is going to be competitive. There are some additional programs that have supplementary applications. So for something like health sciences, there's going to be a supplemental application. It's going to be an essay style written response. Fine arts, dance and music has an audition, and then fine arts visual studies has a portfolio. And then all students must also meet English language proficiency requirements. These are just the specifics for our geology program. So you can see here, English, that one's a requirement across all fields. So no matter what program you go into, you're going to have that English class. Alberta Mathematics 30-1 or equivalent. So if you're out of province or out of country, we're just looking for that pre-calculus equivalent class. And then 2 of biology, calculus, chemistry, physics, or computer science. So it's just a combination of those 2 there. And then an approved course or option. So that approved course could be an additional science class, an additional math class, a social studies class, or an approved option could be something like phys ed, a fine arts class, something like that. And the admissions average that we're looking for is going to be in the low 80s. So that's going to be a combined admissions average of those 5 classes. And then these are just some important dates that we have. So for any students who have a current offer for the university for fall 2024, you're probably pretty familiar with these dates. The one coming up for you guys will be the May 1st decision deadline, which is actually going to be next week. And that's your deadline to accept your offer and pay the admissions deposit. For any students who haven't submitted an application or are interested in submitting an application for fall 2025, these ones are going to be the dates that you're going to be seeing. So August 1st, our admissions are going to be open for international students. October 1st, it's going to be open for domestic students, and then it closes on March 1st. So you've got that kind of window of time to submit your application to our programs. If you're really interested in geology, that'll be your time to kind of do it. If you're interested in that geoscience or anything in that, Department of Earth, Energy, and Environment, I think.
Correct.
Yeah, okay, perfect. I was like, I think I got it. I'm going to try. And then these are just a couple of ways to connect with us. So we have different recruiters for regions all around the world. So it's just the QR code here on the left-hand side of the screen. You can download our current viewbook in the middle of the screen here at that QR code. And then we also have all the different ways to connect with us and kind of stay up to date on all things UCalgary. So if you're not sure who to reach out to, you can just reach out to the future students email that's just up there. We also have a Facebook, an Instagram, a Pinterest, a podcast, and also our Choose UCalgary YouTube account. So if you're interested in rewatching this sample lecture or watching any of the previous ones that we've done, or any of the 2 that are happening next week, you can go and check out the Choose UCalgary YouTube channel. And we're going to be uploading all of the sample lectures there for you to rewatch and watch again. And that's all that I have for you guys tonight. If you do have any questions regarding admissions or anything about geoscience, please feel free to put it in the chat or the Q&A box, and we'd be more than happy to answer them for you. I'll probably just answer over chat so I don't, speak over top of anybody. So I'll just open up the floor to any questions that we have. I'll probably say about 2 minutes here. So if anybody has any questions or comments, please put them in the chat. I'll also just check, we are live streaming on Facebook, so I want to make sure that I'm not missing anybody over there. And then if you do have any questions after today that maybe something comes up, or you think of something, you know, you wake up from the dead of sleep tonight and you think of something, please feel free to send us an email. Yes, I will be uploading the generative AI lecture on the YouTube channel at the end of the day tomorrow. So keep an eye out for that one, Ryan. That one will be up soon. So don't worry about that. Awesome. I think if we don't have any questions yet, I think we'll probably sign off for tonight. So thank you for joining me today, Rajeev. It was really great to hear about geoscience and just kind of everything that geologists do in the real world and how they kind of, you know, help with the science world, but also just kind of like our day-to-day lives. It was really, really cool to listen to you speak.
Thanks, Kara.
Thank you so much for everyone for coming tonight.